The emergence of life. Our planet is always changing. At some point, billions of years ago, our planet changed from one that did not have life to one that had life. How did that happen? When did the first living cells appear? There were about 700 million years between the time when Earth began to cool and the oldest known bacteria fossils were formed. That's a very long time. About 10 million human lifetimes, about 70,000 times longer than all of human history. Chemical reactions were occurring throughout the planet, but especially in the newly forming oceans. These reactions released energy, but by themselves they were not life. However, they would provide the energy that would be essential to early bacteria. As Earth's crust cooled and solidified, water vapor condensed. It rained for 100 million years, and the oceans formed. For many years, most scientists believed that water was brought to Earth by meteorites in the early solar system. But that cannot explain the large amount of water in our oceans. There must be an additional source. While this is still a good hypothesis, other hypotheses have been proposed more recently. Lunar samples taken during the Apollo missions of the 1960s and 1970s showed that the water found on lunar soil particles matched water particles on Earth. This tells us that the Moon and Earth probably got water from the same source and not just from meteorites. This discovery suggests additional hypotheses about where Earth got its water. What is the source of our water? Could water vapor have been carried from the sun to Earth and its moon by solar wind? Could it have been carried to Earth as the planets formed from other planets, such as Jupiter or Saturn, when their early orbits crossed Earth's path? There are several hypotheses that could explain where our water originated. Our water probably has more than one original source. 3/4 of Earth's surface is submerged in water. Water is fundamental to life on Earth. Why? A water molecule consists of 2 hydrogen atoms and 1 oxygen atom. It is an example of a polar molecule. One side, or pole, has a more positive charge than the other. This is important to the behavior of water and its impact on life. The polarity of water gives it several important properties that allowed life to emerge on Earth. Water moderates temperatures in its surroundings. Water dissolves most substances. Water attracts other water. It is cohesive. Water has a very high specific heat. It takes a lot of energy to raise the temperature of water even a few degrees. This means that temperature on Earth's surface is moderated by its water. The temperature doesn't get too hot or too cold. Why is this important in the development of life on Earth? Water is sometimes referred to as the universal solvent because of its ability to dissolve most compounds. Life's chemical reactions need to occur in solution. Nutrients can dissolve in water, allowing chemical reactions to occur. The dissolving of compounds in water also lowers its freezing point. The polarity of water molecules cause them to be attracted to each other. They stick together. The positive hydrogen side of one molecule is attracted to the negative oxygen side of another. Attraction between molecules is called cohesion. Among other things, this property allows plants to pull water up through their roots, small insects to walk on water, and ice to float. Cohesion is a factor contributing to the high specific heat of water. The Earth's fresh and salt water contain dissolved oxygen, which is used by aquatic organisms to live. As temperatures rise, water holds less oxygen. If temperatures rise high enough, too little oxygen is available to sustain many forms of aquatic organisms. About 252 million years ago, at the end of the geologic period known as the Permian, almost all aquatic life became extinct. It is thought that global temperature increased as a result of the vast release of methane and carbon dioxide into the atmosphere. This resulted in levels of oxygen in the Earth's surface water that were too low to sustain most forms of aquatic life. 96% of marine organisms are estimated to have gone extinct during this time. Can the Earth's marine life be at risk again? Click for video.